This video is on the rules for operating on integers. We all know that operations on numbers involve addition, subtraction, multiplication, and division. So to add integers, we can sing this song to ourselves using the tune to Row, Row, Row Your Boat. Same sign, add and keep, different sign, subtract. Keep the sign of the larger number and then you'll be exact. So let's do some examples. If you have negative numbers, -3 and -4, the negative sign is a directional signal telling you that you are going to the left on the number line. So you're going the same direction for both numbers and you will end up at -7. But if you have an example that has different signs, as in the song above, your different signs mean you're going to go in two directions. So in this case, you're going to go 5 to the right, and then you're going to come back left 2. So you're left with the difference between these two numbers, and the larger number is the one that keeps the sign of, the answer keeps the sign of the larger number. Subtraction is a little more difficult to visualize, so we're going to look at 3 different ways to think about subtraction. The first way is in number jumps. So you have 2 and you want to subtract 3, so we start with 2 on the number line. And then we're going to go to the left because we're taking away +3, so we're going to move to the left and we're going to arrive at a -1. The second example is a -2, and we are going to take away take away 3 from the -2. So again, we are going to the left and we will arrive at a -5. Now the third example is a little more difficult to visualize, but if you think of subtracting as going in the opposite direction of the number that you're subtracting, we could think of it that way and it'll make a little more sense. So you start with -2 and you want to subtract a -3. The -3 would normally go to the left on the number line, but since we're subtracting, we're going to go in the opposite direction and we're going to go 3 over to the right, and we will arrive at a +1. And the final example is 2 minus 3, and I think that is actually the same example as the first one, so I'm going to zoom through it. My mistake. Okay. The second way to think about subtraction is that it is the difference in the distance between the numbers. Let's look at that. The first one is easy, 3 minus 2. We'll look at the distance between these two numbers, and the distance is 1. We are going back 1. So that becomes our answer. 3 minus 2 is 1. The second one is a -3 and a +2. -3 subtract a +2. If you look at the red line, the distance between these two numbers is 5. Now I made it red because we are subtracting from a smaller number. -3 is the smallest of the two numbers, so -3 is on the left, and we are subtracting a bigger number. So we're actually going in the negative direction. So our answer is going to be a negative answer. Okay, in the third example, is we start with a +3 and we want to look at the distance between a +3 and a -2. So that's this distance. Now we have the larger number on the left, so we're taking away a smaller number, the negative number, and that means that we're going to be left with a positive answer. So 3 minus a -2 is a +5. And the little guy in the bottom corner is kind of telling you the rule to this. In the final example, we'll start with -3. We want to know the difference in the distance between -3 and -2. So we look at those two numbers, and because -3 is smaller than -2, it is a negative answer, and the distance is a -1. Okay, and the third way we've done in class with integer chips, so let's just model this again. Subtraction is taking away. The first example is the easiest one to see. 3 minus 2 is 1. So we have the yellow integer chips are positive and the red integer chips are negative. So in the first example, we had 3, we took away 2, and we left with our answer of 1. we'll go to the example just below the first example, and this says we have -3, so we see the 3 red integer chips. We're going to take away -2. So when I do that, I cross off -2 of them, I can take them away, and I am left with a -1. Okay, the next two examples are a little more difficult to see, but once you get it, they're very, very easy. So let's talk about these. I start with 1, and I want to take away, I want to subtract a +3, but I don't have +3 there. So I'm going to add 0 pairs because the value of a +1 and a -1 is 0. So I'm not changing the value of my number, but I'm adding enough 0 pairs so that now I have 3 positives. So I'm going to take away those 3 positives, and I'm left with 2 negatives, which would be my answer, -2. Okay, let's try the last subtraction problem. And we start with a -2, and I want to take away a +3. Again, I don't have +3 to take away, so I'm going to add some 0 pairs so that I have enough positives so that I can take 3 away. I'm going to take away those +3s, and I am left with a -5. It's a little easier to visualize subtraction with integer chips, but there are some rules that we can use so that we don't actually have to use number lines or integer chips when we're just doing problems on our paper. So the definition is subtracting a number means we're going to add the opposite. So when you see the subtraction sign, we're going to change it to an addition, and we're going to change the sign of the next number after it. So we're going to add the opposite. And remembering this particular situation will help you avoid a very common mistake. When you are subtracting a negative number, the 2 subtraction signs, the double negatives, just like in English, cancel each other out, and it's just like adding a positive. Okay, so you're going to subtract, or you're going to add the opposite, which means change the subtraction sign to an addition sign, and the opposite of a negative is a positive, so these two would both be positive, and it would equal a positive. The last part of this is multiplying and dividing integers, and it's actually very easy. This is easier than subtraction. There's just 2 rules you have to remember, and they're the same for both multiplying and dividing. The first is that if the signs are the same, then the answer will be positive. So if you have a positive times a positive, or a positive divided by a positive, the answer is going to be a positive. And that holds true for a negative times a negative equals a positive, or a negative divided by a negative equals a positive. Now, if the signs are different, you have, let's do an example. So in the first example, a -5 times a -4, the signs are the same, so 5 times 4 is 20, and the signs were the same, so it's a +20. In the division, a -10 divided by -5 is a +2 because you have a negative divided by a negative. Okay, so now let's get to the second half of this. If the signs are different and you're multiplying a positive by a negative, or you're dividing a negative by a positive, then your answer will always be negative. 2 examples of this would be a -7 times a +7, and your answer would be a -49. And for division, if you divided -7 divided by a +7, you would have a -1. Now in division, it does not matter if the negative number is on the top or the bottom. It will still result in a negative answer. The only difference is, well, you just have to make sure that one of those 2 numbers is a negative. And it's very important to keep track of your signs. One of the most common mistakes in middle school students is to drop a negative. So keep track of your signs. That's all. Thanks for watching.